Okay, so the second example here, which has to do with these basic identities that we spoke about earlier, is going to be a little more involved algebraically, but the actual trig, once we remember the algebra, will be very reasonable. So this little typo here, so let's make sure we fix that. If you have that in your notes, please make that a plus. So what's going on here algebraically is that I need to combine this rational expression. And the way you do that is to find a common denominator by basically multiplying this denominator over here, and then multiplying the denominator on the left on the right. And what that does is it finds a common denominator. Don't forget, you also will have to do it on the top. And the mathematical reason for that is if you have the same expression on the top and the bottom, if you were to divide it, it would be 1, it wouldn't change it. This is exactly the same as in elementary school when you had maybe like a half and you had to add 5/3 to it. You would multiply this by 3 over 3, and then you would multiply this by 2 over 2 so that you could add it together. So for instance, this would be 3/6, which of course is still a half, and this would be 10/6, which of course is 5/3. But now that these are the same, I'm adding out of sixths. It's like a variable actually. So now that I have the same variable, I can combine the like term in the top and get 13/6. So that's the concept over here. In order to have a common denominator, I multiplied this over there and that over there. Okay. And so we're going to multiply those two things together. And you can see now I have x plus 1, x minus 1. And over here, I also have x plus 1, x minus 1. All right, so now that I have the same denominator, just like here, I have the same denominator, I need to find the numerators. So here I would have to distribute this, okay? So this would just be x squared plus x. And then this over here, I would have to FOIL. You could also use the box method if you prefer the box method. Okay, so to do that one, we would get x times x, which is x squared. Then x minus 1 is negative x. And then x times 2 is 2x. And then 2 times negative 1 is negative 2. Now what happens here, just like here, these two sixes were the same. Now my denominator is the same. I have x plus 1, x minus 1. And then here what I'm going to do is combine like terms. So I'm going to combine my x squareds together. That would give me 2 of them. Then I'm going to combine my x's together. And then my last thing I have left is this constant, which actually doesn't have any other like terms. So if I put those together, the first one would be 2x squareds, because I have 1x squared plus another one. Remember, there's ones in front of here. And then here I would add x minus x, which would cancel, and then I would have left over 2x. And then the last thing I have there is this negative 2. And so that would be the answer, just like this 13/6. But the problem is that you actually don't know if the top will cancel. It's very obvious that there's nothing in 13 that'll cancel with 6. If that were a 12, though, right? If this was a 12, you would have a different story. So in algebra, and again, why are we reviewing the algebra? Because the trig comes from the algebra. So what we have to do here is we have to take out the common GCF, which is a 2. And that would give us 2 times the function inside, and then we still have that denominator, which we'll talk about in a second. So this actually will not factor because 1 has factors of 1 times 1, and it's asking you to subtract them. So if you did subtract them, you would get 0. So this does not factor. And once you know that it doesn't factor, that's when you then have to FOIL the bottom together in an algebra 2 situation. Or calculus, this is like a pre-calculus concept as well, but you learn it for the first time in algebra 2. So you would get x squared minus x, then plus x, and then minus 1. These would cancel. So that would be your final answer. Some people would say that that should be on the top. Either way, you might have that numerator and that denominator. So all of that it's like a pre-knowledge for how do we do this trig problem. Okay, so remember, when you do this trig problem, this is the answer they're trying to give you. So imagine in algebra 2 if they said this and then they said, hey, it equals that. That way you know where you're going to at the end of the problem. So we're going to work the left side, and what we're going to do is we're going to go back over here. Okay, so secant is 1 over cosine, right? And cosecant, we haven't used it yet. I'll put that in purple for you. So these are the two things that we have in that problem, these two items. So let's go back to that problem and let's just substitute. Secant was the one you saw in purple. It's 1 over cosine. And cosecant, again, let's just go back 2 slides. Cosecant is, oh, sorry, I put those out of order. Cosecant was the one in purple and that one's in green. So I'll just color code those right. Fix that real quick. All right, so this one was 1 over cosine. I'm just color coding them the same as you saw a second ago. And then this one is 1 over sine. I got those again from those identities we talked about initially. The plus sign does not change. It's still a plus sign. So now we actually have a situation that's actually more similar to this problem, where we have a 1 on the top, but we don't have the same denominator. So we're going to do the same thing. We're going to multiply sine over here and on the top, because again, anything divided by itself is 1, which doesn't change anything. But then over here, we're going to multiply by cosine because it doesn't have a cosine. Just like this didn't have a 2, same thing I'm doing here. Okay, so now what we're going to do is we're going to multiply this together, and you can already see my common denominator is sine cosine. What's great about these trig identities is it already tells me that's what I want. Look, we already have that. So that's good news. We know we're on the right track. All right, so if I multiply this together, I get sine x, because sine x times 1. There's really a 1 here, but that we don't put that there. And then the other one over here is 1 times cosine, which is cosine x. And then, oh, I have a common denominator, just like here. See how I have 2 6s? But when I write it down, I combine those denominators into 1, like this, and then I would add these together. So in the world of algebra, in the world of elementary school, you have 3 plus 10 is 13. In the world of algebra, you combine like terms. But if you don't have like terms like here, you just write them in order. The order for trigonometry is sine and then cosine. And hey, look, I have that. So that's done too. I have exactly what they told me to get. Remember, your goal is for this to match this. All right, we're going to look at some additional identities next, but this is the end of the examples for the what people call basic identities.